Hello, my name is Coral O'Brien. I will be talking about glucose for my final project for History of Chemistry with Dr. White. What is the biological importance of glucose? If you've been in any biology lessons, you know that glucose is necessary for most life on Earth. Living beings convert glucose into many adenosine triphosphates, ATPs, via cellular respiration. Cellular respiration is a combined term for many reactions in the body. So here's a little diagram that tells you what cellular respiration does. First step, you have a glucose molecule, and you go through glycolysis, and you get pyruvate and 2 ATPs. Then you take the pyruvate, and it converts pyruvate oxidation converts pyruvate into acetyl coenzyme A. Then it goes through citric acid cycle, which is also called the Krebs cycle, and you get 2 more ATPs. And then the electrons go through electron transport chain and yields many ATPs. So why do we want ATPs? Well, first, ATP is made from one adenosine, 1 ribose, and 3 phosphates, triphosphate. So ATP is the energy currency of life. And it releases a lot of energy with the 3rd phosphate group is broken right here from the ADP, adenosine diphosphate. Di means 2. And it releases 30.5 kilojoules per mole under standard conditions. So the cells then use this energy released by the ATP to do its anabolic activities, which is building and making in your metabolism. So we know why it's important. How do we get glucose into our living things? Glucose comes from photosynthesis, which is a process that converts carbon dioxide, water, and solar energy into glucose, which is what we want, and oxygen gas. Photosynthesis is only performed by plants, algae, and bacteria that have chloroplasts in them. So those organisms who cannot perform photosynthesis, like us humans, will have to consume or eat those who can to obtain the essential glucose that we need for life. So we talked about why it's important and how do you get glucose. What does it look like in the molecular level? So glucose has molecular formula of C6H12O6, which is 6 carbons, 12 hydrogens, and 6 oxygens. And glucose is a monosaccharide. Mono meaning 1 and saccharide is sugar, so 1 unit of sugar. And glucose can exist as a linear or cyclic. Linear meaning like that. Cyclic meaning like a ring in equilibrium. They exist at the same time constantly. And with the cyclic, the ring structure, there are alpha glucose and beta glucose. The only difference is that the alpha glucose has a OH group at carbon 1 on the opposite side of carbon 6. And then beta glucose has that OH group on the carbon 1 on the same side as carbon 6. So we know that they have the same molecular formula, which we know that that's an isomer. And only one molecule is in a different place in space. So we call that stereoisomers. So alpha and beta glucose are stereoisomers of each other. So other isomers of glucose are two sugars called galactose and fructose. So here are their models right here, as you can see. And it's worth noting that galactose and fructose both also have cyclic forms that have alpha and beta. And they're both monosaccharides also. So joining two monosaccharides via dehydration synthesis, which is taking a water molecule out to make a bond, and you get a disaccharide, which di meaning two and saccharide meaning sugar, so 2 units of sugar together. So common disaccharides include maltose, which is wheat sugar. You get that from 2 alpha glucoses. You get sucrose, which is our common table sugar, which is 1 alpha glucose and 1 beta fructose together. And then lactose, which is milk sugar, you get from 1 alpha glucose and 1 beta galactose. So now we know the biology and the chemistry of glucose. We can now learn about the history of sugar. So long ago, sugar was made from sugar canes only grown in Asia and the Middle East. And sugar was a luxury only the rich people could afford many, many years ago in Europe. So in this picture, two people are making wine in the medieval times. They would have put some sugar in the wine to make it taste good, taste sweet. So hundreds of years later, after the West Indies were discovered, the colonists brought sugarcane over here to see how well it will grow, and they found out that sugarcane grew really well in the tropical and the southern areas of the Americas. And because Europeans love sugar so much, the colonists wanted to grow a lot of sugar so they can sell it back to Europe. They realized they didn't have enough physical labors. So that's when the slave trade really started to get up and going. So slaves were shipped from Africa via the Middle Passage to the sugar plantations in America. And sugar was the largest commodity in the triangular trade. Not only did they ship sugar, but they made rum and molasses from sugar, and Europeans also loved those products too. And all this went on for more than 300 years. So conclusion and summary. Glucose is essential for most life on Earth. Glucose is a product of photosynthesis. Glucose makes most of the sugars we enjoy. And sugar was only a luxury item that the rich could afford a long time ago in Europe. And sugar played a big part in the triangular trade and was the biggest reason that slaves were traded and resulted in heartbreak and misery of millions of people. So think about all of that next time you have a little sugar. And here are my sources for all the pictures I used in the PowerPoint. The works cited page for the information and ideas materials is with the paper that goes along with this presentation. Thank you.